That's going to be sufficient for a larger camshaft. Again, with the larger cam, we're going to be losing some torque at idle, or for cranking, I should say, idle and cranking. We want to go run a little bit more spark advance so we can build a little more cranking torque. That'll allow the engine to crank over a little bit quicker and fire off and run and not have any kind of issue. So 15 degrees should be a good starting point. The crank to run RPM, this signifies where we know it's exiting the cranking RPM into the run mode. So the default here is 400 RPM. So if it exceeds 400, it's going to be converting it and putting it from the cranking fuel table into post-start, also into our main fuel table. It's going to be doing that transitional period, step from cranking to run mode. We'll leave it at 400. That's usually sufficient here, 350 to 400 for almost any engine. Rev limiters. We have a main, this is default again, the main over rev, the type spark high only. We have a soft cut, leave it on spark high only. High engine RPM, 6,800. Now, factory, this engine was around, I think, 6,600. So that's what I'm going to do here. I'm going to put it at 6,600. I want to kind of stick with what factory had with the rev limiter. I don't want to over rev this. This is a stock bottom end. We're not going to go up to 7,000 or something higher than that. We're going to be conservative with this. So our main rev limiter is spark cut and at 6,600, kind of mimicking what we have stock. Rev limit 1, that's our secondary rev limiter. If we wanted to have a two-step, we could turn this on and set that up. I'm not going to do that. Launch RPM we're not using in this application. ESC parameters, this is our knock control parameters. So the retard per ring, it's going to be 1 degree of ignition retard every time it oversteps 80% knock level. Timing restart rate is going to be adding 1 degree every so often. I can't remember the exact amount of engine cycles, but it'll be adding the timing back in, whatever it's taken out, once the knock level drops below 80%. And then in our actual table here, it's going to be our load versus our engine speed, the values in the table. This is going to be how much ignition timing we're going to allow it to have the authority to take out against our main spark timing table. If we're commanding, let's say, 28 degrees at spark timing at wide open throttle, and we're seeing a knock event, our knock level exceeds 80% with our knock control. If we put a value here up to 4 degrees, if we're finding that it's excessive enough and we're finding that it oversteps the 80% threshold long enough, it'll be allowing it to take out a total of 4 degrees against our spark timing table. So the timing would go from 28 to 24 degrees. Once the knock level dropped, it'll start to restore that timing back in 1 degree per, and I can't remember the exact amount of steps it moves in, but it's going to be either engine speed or time. I don't remember. Degrees per second. All right, so there it actually specifies, so degrees per second. That's actually going to be a relatively slow restore rate depending on how bad the knock event it is and how much authority we're allowing the max timing retard to take out. Now, in this table here, I'm going to program it from 2,000 RPM and higher, and I'm not going to do it in part throttle, so I'm only going to focus here from 76 and higher. So, actually, let's do 114 and higher. I'm going to let it take out up to 6 degrees timing here. The rest of the table here, low engine speed, 0 to 1300, that's going to be idle, and then 76 kPa and below, that's going to be part throttle. I don't want my knock control kicking in there, but I will allow it to take up to 6 degrees out. So we'll get into that. We'll try to set it up. Hopefully it works. If it doesn't, we can turn it off, but that should give us a decent starting point. The timing versus coolant temp. We want to go and populate this. The bottom axis here is in coolant temp. The values in here are going to be a offset or modifier against our main spark timing table. So on a cold engine, on a cold coolant temperature, we want to make sure that we go in and actually we take a look at this table. It's not even set up here for our coolant scale. So we need to go and set up our coolant temp scale here so it's accurate. That's going to be a big problem. The table is not going to be applying the timing correction right. But what we'll find on a cold engine is we need a little bit more spark timing because the engine's going to have poor atomization of the fuel. That's going to lose some engine torque. If it loses engine torque, the only way to get that back is to increase airflow from our idle stepper motor, trying to get some more air into the engine, or adding some more spark timing to gain back lost torque. We're going to go and add a little bit more spark timing in here. It should stabilize the engine. It should give it a little bit more idle torque. It should make it run a little bit smoother and come up to operating temperature a little bit quicker. So we need to fix this coolant temp scale. I'm going to say, let's go put this coolant scale at the max here of something like 280. Click enter. And then we'll go and do horizontally interpolate this. So we'll go here from -40 all the way out, and we'll highlight it all the way out to 280. We'll right click, fill row values. Now we can see that's more appropriate for a coolant temp scale. So from 88 degrees and below, I'm going to allow it to add up to, let's say, 6 degrees of timing. At 109 to 131 here, I'm going to go and just highlight between these two. I'm going to right click and do fill row values. Now, my hotter temperatures here, 237, 259, 280, I'm going to take out spar timing. I'm going to reduce the spar timing so we cannot damage the engine, or it's harder to damage the engine. Can't say we cannot, but we can make it more difficult for the engine to get damaged by going in and pulling some spar timing out. Now we've offset our target air fuel, remember, at our warmer temperatures, so we'll do the same thing.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.